Most of you know what is dimension table. As long as you will bring the keyword or business descriptions or textual information, then that context, the table definition would be fine. It don't need to be exactly what is the dimension table. Okay, and again the fact table is basically storing the numerical values, measure the part of the business or whole of the business. It can be a sales and a minimum price and maximum price, and then in our context. Okay, I directly spoken about granularity on last week, but I need to explain relationship first, then only the relationship and granularity is little related, but relationship is little different. Okay, there are four type of relationships between two columns. Okay, I will be bringing the data quickly. So one is one to one. We talked about it while we designing the dimension table. Another one is one to many, another one is many to one, and another one is many to many. When we designing the dimension table, we used one of the rule, group one to one business description columns. Okay, this is specifically talking about this one to one relationship. We were trying to identify one value in one of the column is related to only one value in the other column or many values in the other column. If one value in this specific column name is related to many values in the other column, then we are not grouping them together, we are grouping into the different groups. The product group name and product name, if we look at it, take any one of the product always related to one of the product groups. So that's why we grouped it together. This is all one to one relationship. What indirectly I would like to tell you is that all of the values in the dimension table always will have one to one relationship between the other columns in the same dimension table. Okay, if it's a different dimension table, it will be different case, but within the same dimension table, one of the value in one of the column is always related to one value in the other column. Okay, that is the nature of the dimensional modeling technique, and we call it a star schema because these dimension tables are revolving around the fact table, because fact table has got the keys for all of the dimension table surrogate keys. This looks like a star like structure. I will try to simulate that one here. Hopefully it will come in the star like structure. Okay, that's why they call it as star schema. The fact table is revolving around dimension tables in the star structure. Hopefully you will agree that it looks like a star. Okay, so it's called a star schema for this nature. The dimension tables are revolving around the fact table. That's why it's called the star schema. There is one more schema called snowflake schema. It is the extension of the star schema. Just now we told that each value in dimension table is related to have one to one relationship with the other column values in the same dimension table. That's what we found out now. But in some of the dimension table, specifically if you take the date dimension table, okay, the other columns in the same table can have one to many relationship. For example, is it little visible, the date key and the date, or you would like to copy this into the, probably I will copy into the Excel sheet. When we created date key and we call it as date ID and date, each date will have only one date ID. That's how it looks like. But as soon as you start to include some other information, for example month and quarter, probably we'll start with month first. As soon as you include month information here, again I will select all and copy with header, because here it's not allowing me to maximize it. Hopefully you would be able to see that one. Okay, so here this month values repeating. The last time I have started it, and month name is started as well, repeated here. Okay, even though this value is, the date value is unique for all of these months, when I am defining the dimension table, I have asked to check in the both ways take one column value in this table, is it related to only one value in the other table? In the other way as well, you can take one value in this value, how many values it's associated. For example, in this case, this one, the value is associated to 31 different dates. That means this has got the one-to-many relationship. Okay, in these instances, okay, still it's valid. Okay, the month ID we will keep it in the same table. What we will do is that we will create the another table with saying that month ID and month name. Here it will have only distinct values of month ID here. Okay, probably I will try to use the Excel, remove duplicates. It will have only 12 month values here. In the same way, month name also, if we remove the duplicates here. Okay, so the new table will have only the distinct month ID and month name. We will remove this month name from the original date dimension table. Now I will go back to our star schema. So here we will have the dim date include the only month ID column. Okay, here the month ID values will get duplicated, and we will create the another one table with, we call it as dim month, and I will copy this one across this one. It won't have date ID or date values. It will have month ID value, and here we will have the month underscore name column. So the last column don't no longer appear. So this dimension table is not going to be linked to the fact table. This table is going to be linked to the existing dimension table via this month ID. Okay, what here we are trying to avoid is this unnecessary month name duplicates appearing in this dimension table. We are trying to avoid it. That's what we are trying to do. If any dimension table has got one-to-many relationship with other dimension columns, then we keep the ID column in that main table, all of the associated values into the other table, and we link the dimension tables together. So this structure is called the snowflake schema. Snowflake schema is the extension of the star schema. These additional dimension tables don't directly link to the fact table by any time. It always link to the dimension tables. So whenever this one-to-many relationship existing in the same dimension table is logically related, we create the other dimension tables. This is purely saving the data space and also giving the clear distinction between the different dimension tables, because even though the month ID is repeated in the other table, here the original primary key of this table is date. The date is not repeated. At date level, still this table is at one-to-one relationship. And this month ID is the additional column we created it, and it will link to the other dimension table. Here again you look at it, each month will have only one record. So this is the snowflake schema. Probably if they ask, do you aware of the snowflake schema, you need to explain in such a way that if one-to-many relationship in same dimension table, hopefully you can able to understand what I meant. One-to-many relationships in same dimension table, then we split the dimension table into multiple tables with linking ID columns. Okay, it don't need to be at only one level. It can go to one more level as well. For example, if you take the quarter values here, the original thing, if I take the quarter information again, it will be repeated here. So you need to create the new, for example, I think in this table quarter name is not there, first quarter, second quarter, third quarter, fourth quarter. So in the month table, not in the date table, we probably keep the quarter. In the month table, we will include the quarter information. For example, this will be in the first quarter. Hopefully I'm all right. There are only 4 quarters in a year. So 2 2 and 3 and 3 and 3 and 4 sorry, 4 and 4 and 4, and we will create separate quarter dim quarter table with distinct IDs in this one and the description for those quarters. So you can go to any levels from root dimension table into sub dimension tables. Okay, this is not advisable until otherwise your business has got too much relationship between the dimension attributes. Okay, some cases it will be like that, then only it needed. Star schema is the best preferable approach for reporting solutions. It will resolve so many problems, but we need to aware what is the snowflake schema. And the other question, okay, I mixed up relationship and granularity last week. The granularity is little bit different from the relationship. Granularity is basically identifying what combination of column values identifies the unique record in the fact table. That is what the granularity is related to. In our case, if you look at our fact table, the lowest information of the price is captured at date level. Okay, for the product, for the market, for the date, for the variety, I think variety also included. For the product, for the variety, for the market, the state name is not deciding the price, in fact, actually. Okay, the markets are belonging to state name, that's why we included the state name, but the original price is captured at variety of the product selling in the market on the specific date. That is the granularity. These 4 combinations will give us the unique record for each of the pricing information and arrival in quantity that we are capturing it here. So what is the lowest level of the data that we are storing in the fact table? That is what called related to the granularity. It is not decided by us actually, it is decided by the source data. If source data is captured only at the month level, we wouldn't be able to store that at the date level. We can't able to derive date level data from the month level data. It is not at all feasible. So the granularity is decided by how the source data is captured. That is the main thing here. So one of the terminology we need to aware of that one. And relationship between columns in dimension table, this is again we just now discussed. It always need to be 1 to 1. If it is going to be 1 to many, then we need to define multiple dimension table. That is called the snowflake schema. And what is the normalization type? Okay, there are 3 normalization types are there, and I think it's little out of the scope for us. This is purely used on designing our source systems, and the rules always will give you the too much confusion. If anywhere the question will come across saying that what normalization type the dimensional model is following, it is at the normalization type 2. The one thing you need to keep in your mind is that we know that all of the values are unique, 1 to 1. Okay, 1 to 1 in each of the dimension table, but when it connects to fact table, given a state ID, there will be multiple state names are there. Okay, with respect to join between dimension and fact table, it's always going to be 1 to many. Okay, so that is the logical relationship that you need to aware of it, how the data stored in dimension table and how the data is stored in the fact table. And that's what related to this type 2 normalization technique. Okay, and the difference between logical data model and physical data model. So the logical data model is designed based on the business requirement. It is not including the how it will be implemented in the physical database. They don't worry about it when doing the logical data model, but when coming to the physical data modeling, we will be worrying about how it can be implemented in the underlying database. That is the main difference between physical data model and logical data model. And what is conformed dimension is a dimension can be shared between more than one fact table, then that dimension is called conformed dimension. So at the moment we are capturing only the pricing information in India. For example, we are capturing the pricing information across the world, then obviously the product name won't change in different countries. The apple is called as apple in all of the countries. Okay, so these type of dimensions are called conformed dimensions. Okay, so yeah, same dimension can be shared between multiple fact tables, then it's called the conformed dimension.